Good afternoon, ladies and gentlemen, and welcome to our WTW or WTW webinar. We're very fortunate to have two presenters today, one in Tokyo and the other in Delhi, India. So a very international webinar today. Our topic is online wastewater monitoring of COD and BOD with spectral sensors. Today's webinar is actually part two of a four-part WTW series. If you joined us for our last webinar, thank you very much. It was held on June 25th on how to monitor BOD with the OxyTop. That will continue with part two this week on July the 9th. And on July 14th, we have photometry basics and automated chemistry analyzers. If you'd like to register and have not done so far, there is a registration link on our .asia website. The domain name is displayed here on the screen. Following this webinar, there will be an email sent out to all of you with a link to the recording of today's webinar, as well as a certificate to prove that you actually attended the webinar. And we'll also include information on how to register for our other Xylem webinars, including this series on WTW. So our first presenter from Tokyo is Dr. Tao Su. Dr. Tao has a PhD in environmental science from the Tokyo University. He's accomplished 5 years of research with the Tokyo University and has been with Xylem for 3 years. He's currently the product manager for WTW instrumentation. And before we bring Dr. Tao on, I'd like to invite the audience at this time to participate in our first poll question, which is now being launched on the screen. Where are you currently monitoring BOD and COD? Industrial, municipal, or environmental rivers and lakes? So we do invite you to respond by simply clicking on the actual blue screen that you see on your PC. And while our audience is responding, I'll take this opportunity to bring our guest speaker, Dr. Tao. Please come on stage.
Hello, Michael. Thanks for your introductions. Hello, everyone. I'm very excited to have this webinar with you. Welcome to join our WTW webinar. I hope you have a very good day today.
Thank you, Dr. Tao. And it looks like our audience has almost completed responding. We'll just give a few more seconds.
Okay, I think in most of the audience will be very interested for the BOD and COD environment. I guess most of the audience will select industrial water because many countries recently have very strict regulations on for the effluent. So I guess the industrial company will be very interested with BOD COD environment. So let's see the result.
Okay, we're sharing the results now. And you are correct, Dr. Tao. It looks like 53% of our audience are currently monitoring BOD and COD in the industrial sector, followed by 31% in environment and 17% in municipal.
Yeah, it's what I can expect. But I'm very interesting because many of our other audience have selected environmental. It's very interesting.
Yeah, very interesting. Well, I'll let you take it away now.
Okay. So now I will start my presentation. Today I will focus on the BOD COD monitoring technologies. As we know, water is an important material for all living animals. Therefore, it is a precious resource to human beings. However, with the development of the social economy and human activities, our water are encountering serious pollution, which now is threatening the security of our water source, of course, our human beings' life. So, a standard method for checking water quality has been developed. As we know, BOD COD has been widely used. So could Michael help to for the poll question 1?
Sure, Tao.
Yeah,
Launching right now.
yeah.
How are you currently measuring BOD, COD in your applications? Using lab method with online TOC monitoring, lab method along with UV254 based online monitoring, or lab method along with UV vis spectral sensor monitoring. So we'll just
Yeah.
give the audience a few seconds to respond.
Yeah, I guess most of our audience will select the lab method. Actually, the BOD COD method has been around 50 years history, and the standard method has been widely used in all of the countries. So I think the most of our the the people will use the very standard method to use the reagent and to get the BOD or COD result. So I guess lab method will be mostly select.
Well, based on how the audience is responding, I think they are meeting your expectations. Let's share the
Yeah,
results.
yeah, please.
And it looks like 69% of our audience
Yeah,
are in fact using for lab methods.
yeah,
This is followed 22%
yeah,
with UV vis spectral sensor monitoring.
yeah. Okay, this result is very interesting, and it's also we can expect because UV method is very convenient and is a new technology for BOD COD environment. That's why today our WTW uh, will hold this webinar to introduce BOD COD technology. So I also want to say something about the UV method. So next, before I introduce the UV technology method, I will talk about something about the COD standard measurement method. As we know, actually, apart from BOD COD, there are many parameters like pH, turbidity, and TSS, but BOD COD have been widely used because it's a very basic parameters and it can reflect the water quality. This method is it's measured by using some reagent. Actually, most of the reagent used is toxic, like dichromate. Actually, it's a very toxic reagent, and I think all of our audience will know it will require more than 2 hours heating and at 150 centigrade. Oh my God, 150 centigrade and use the toxic reagent. It's not easy and it's troublesome. Yes, some people will say, okay, BOD so it's convenient, no need any reagent and no need to heating samples. But BOD, if you want get BOD result based on the standard method, you will need incubate your samples for 5 days. It means you cannot know your water quality today. You can only know the water quality after 5 days. So it's not convenient. So nearly 3 years ago, a new technology using ultraviolet, we can see UV, to measure COD BOD. By this method, no reagent and no heating is needed. Additionally, you can obtain COD BOD value in only 1 or 2 minutes. I want to say our WTW CoverWith product series is a successful example product developed with this method. So why UV can be used to measure BOD COD? Firstly, it's around 50 years ago, one Japanese scholar named Ogura, who firstly found UV 200 around 200 and 300 nanometer wavelengths can be used to evaluate nature water quality. And then this method has been largely developed. Now we know the principle is almost all of the organic pollutants contain the double carbon bond. This double carbon bond can specially absorb 254 nanometer wavelength. That's why the COD BOD can be calculated, because it has been used basic formula is Lambert-Beer law. I have showed in the PPT. You can see that. This is the basic mechanism of most commercial online COD sensor. By this formula, we can see the concentration of the organic carbon or we can say pollutant is linearly related with the absorbance of the UV. So next, with the research and development, the researcher has found if only by the single 255 nanometer wavelength is not enough, because the UV absorbance spectra, it's actually the peaks is the peaks can be changed due to the different structure and the structure of the carbon source. So with some research, the scholar have found if use the multiple scan wavelengths can correctly reflect the carbon source concentration. So instead of single wavelengths, scanning multiple wavelengths can more accurately reflect the presence of a pollutant. That's why our WTW Carbowitz applies this method to analyze COD and BOD. This method can be much more accurate and much more reliable. The next, as has been introduced by the previous slide, COD is calculated from UV absorbance. So to obtain accurate COD value, calibration is very important. As for the WTW Carbowitz sensor, you can very easily use our template. You can see the slide. Actually, this is the Excel template. You can just input your sensor value and the laboratory environment value, and our Excel template can recommend you the best factor to input in our transmitter. So you can just very easily use our template to monitor to get the recommend factor, and then you can monitor the COD in real time. And I also showed some laboratory instruments in the slide. You can use our WW laboratory instruments to measure standard BOD or standard COD value. Next, apart from our Carbowitz series, I want to also give a very short introduction for our other UV VS sensor, like nitro waste. It can be used to measure the nitrate, and also Nicavis. You can see it shows many different parameters you can measure, and based on your different needs. And also you can use our nitro waste and Nicavis. It's very convenient, and the customer can use it based the different requirements. Not only for wastewater, this also can be used for the surface water. So next, could Michael help us for the poll question 3?
Certainly, Dr. Tao. Launching now.
Yeah.
How frequently do you monitor for BOD, COD? Several times a day, once every day, once a week, or continuously online 24/7? So again, we'll just give the audience a few seconds, Dr. Tao, to vote.
Yeah. Why we ask these questions? Because we know for our standard method, BOD will need 5 days to measure the value. So it's a long time. COD, although can get the date less than 3 hours, but if you monitor your water quality, we want to know how long, how frequently you do this experiment. Some people maybe one day once a day, or some people maybe once a week. So let's see the result later.
All right. It looks like our audience has completed. So let's share the results.
Okay.
And it looks like 40% of the audience monitor once a week,
Or once a week.
followed by 24/7 continuously at 34%.
Yeah, I guess that once a week, the audience maybe uh, related with the municipal government, maybe because as I know, most of the government has allow the industry company to submit this effluent date once a week. So I think they maybe use the standard method is to measure BOD or COD. Okay, so thanks, Michael. So next we can continue our presentation. After some introduction for the UV methods introduction, I want to introduce some application examples by using our WTW UV sensor. Firstly, let us introduce some applications at wastewater treatment plants using our sensors in Japan. As we can see, this is the Japan map. You can see most of our the factors has the application examples by using our carbon-based sensors. In Japan, most of the customers just use the carbon-based tool in the wastewater treatment plant. They monitor the effluent every day, and they found it's very convenient to get the BOD and COD data. And we can see some photos in the slide. One is from the a milk manufacturer in Japan, and another one is from the automobile maker. So actually, carbon-based can be used in different industry companies. Next, we want to see this application actually is from a German wastewater treatment plant. You can see the influent and effluent are both monitored by carbon-based. Next, let's see the applications from Thailand, one of the wastewater treatment plant. In this applications, COD nitrate is I can see it's perfect consistent with the laboratory value. And lastly, not only COD, BOD, as our carbon-based sensor, TUC can also be the TUC value can also be measured. This application just shows this Germany company, Germany WTW wastewater treatment plant use our carbon-based to monitor the TUC value. Okay, so let's give a short summary for my presentations. The UV sensor method is main trend on COD BOD monitoring. Secondly, I want to say WTW carbon-based sensor has been demonstrated a stable and reliable method on COD BOD monitoring. And lastly, I want to say for our WTW UV sensor not only used in wastewater treatment plant, can be also used in service water. I think next our India team, Udit, will introduce the surface water applications of our UV sensor.
Dr. Tao,
yes.
Yeah, thank you very much for that informative presentation on our spectral sensors and BOD, COD monitoring. As you mentioned, we'll now move on to our second presenter, Udit, out of Delhi, India, who will be presenting on point and non-point pollution monitoring. And we'll just take a moment just to switch presentators. Please bear with us. So Udit will be discussing point and non-point pollution monitoring. And just to give you a brief introduction, Udit Kumar has a Bachelor of Science in Physics and Math, and he has over 11 years experience in water quality instrumentation. including 8 years experience in COD monitoring, and has been with Xylem for 5 years. He is our sales manager for WTW online monitoring instrumentation. Udit, thank you so much for joining us all the way from India.
Thank you, Michael. Thank you for the introduction, and good afternoon, everybody. And Michael, like, once again, thank you very much for helping us for this webinar. So I'll start now. So good morning, good afternoon. After the interesting insight into Xylem's unique spectrometry technology, which Dr. Tao already explained, I would spend next few minutes in taking you through several applications and development environment which this technology has been successfully deployed in part of Asia for effective water quality monitoring for regulatory and environmental purpose. In general, pollution monitoring is to trace the source of pollution and then deploy structural or non-structural measures to improve the health of water body. That would result in healthier parameters values, for example, increased dissolution and near pH value like 7 pH. That will be good for aquatic life as well as for human purpose. In next few slides, I will take you through the point and non-point sources strategy that is very effective in addressing the pollution monitoring systematically. So this is basic outline of my presentation, and without further ado, I will jump into it. This is a map showing rivers and lakes in various parts of Asia, and as you all know, these large rivers are major source of water for the region, and therefore it is critical to maintain the optimum water quality besides monitoring them for water quantity for better water resource management, of course. Another common theme across the region is most large cities are located closer to the river. That together will increase urbanization could be adversely impacted the river water quality if appropriate monitoring regime and regulations are not in place to the facilitating substantial growth, ensuring minimum impact on the environment. Water scarcity and access both are a concern, and therefore measuring water quantity along with the water quality provides a true picture of what is happening in water bodies. Especially from pollution perspective, this could be misleading as dilution due to excess water could give false positives, and a scarcity of water could mask improvement in water quality due to increased concentration of pollution. As I mentioned in my previous slide, broadly, there are two categories of source of pollution for water bodies. Number one is the point source water pollution. Second is non-point source water pollution. So point source pollution is easy to recognize because it originates from a single source or event and affects a specific area. This could be an oil spill or discharge pipe from a factory and from a sewage treatment plant. This is since there is a single point of origin, this type of pollution is relatively easy to monitor and control. Non-point source pollution comes from multiple diffuse areas that affects both the immediate and in surrounding areas. A good example of this type of pollution is agriculture runoff, or maybe untreated STP discharge from the villages, from the small towns, from the different locations. Compared with point source, non-point source pollution is often more complicated to identify and address. Impact of water pollution results into destruction of aquatic flora and fauna. There are countless species of plants and animals which are depend upon the water for their survival, so making them the more susceptible to water pollution, causing interruption in drinking water supply and food chain, and eventually it will increase cost of water treatment. Dr. Rao has already discussed about point source monitoring, which is related to industrial ETP and municipal STPs. Monitoring of COD, BOD at municipal STPs and industrial ETP at the outlet enables the plant operators and regulators to check the performance of treatment facility and the quality of treated water they are discharging from the facility. Let's take a look at how we can monitor the non-point source, which is typically deployed in lakes, rivers and other water bodies. Typically, river Monitoring comprises of monitoring at upstream and downstream of a suspected polluting stretches. For example, monitoring of water quality parameters at upstream of the city and downstream of the city will throw interesting insights into what impacts are caused by urbanization, industrialization along with the river, and leads to thoughts on what measures could be deployed to address this issue. Also, continuous water quality monitoring upstream will tell you about how good is the quality of water for drinking purpose for humans, and accordingly will help optimize the process at your drinking water treatment plants. Similarly, monitoring water quality downstream, you can know the efficiency of wastewater treatment plants and if there are any improvement required in treatment plants and trap wastewater, so it can be take necessary action before it released back into the river. With the real-time river monitoring network, you can track trends in water quality over the time and identify emerging problems in the polluting stretches in the river. And for regulatory body, they can use this data and information for setting up new guidelines and regimes. For lakes which are located within the city, they could be seriously facing challenges due to inflow of treated or untreated wastewater getting into them, which causes the deterioration in water quality. Water quality parameters need to be monitored at point source location so that these can be regulated. In addition, basic water quality parameters like pH, DO, turbidity, ammonia, they're also known as environmental parameters, should be monitored in lake water body so that water quality trends can be monitored over a time and in continuous manner. Regulators, often government bodies and EPA, they gave clearance for plant based on consent to operate, and that describe their maximum limit of water quality, key water quality parameters like COD and BOD. So government set some guidelines to the industry and municipal corporation so that uh, uh, government can achieve good water quality in rivers and lakes. So these are the parameter shown on the slide, and there are some limits uh, which should be in rivers and lakes. Like COD should be less than 10 milligram per liter, BOD should be less than 3 milligram per liter, nitrate should be less than 10 milligram per liter. These are limits basically which are healthier for aquatic life for the human purposes. So these limits which we have mentioned here can be different as per the country, region, and their existing standards. Now we comes about spectral sensor use in river applications. So the same sensor which Dr. Tao already described, which we use in industrial and municipal application, we can use same sensor CarboVis 705 701 sensor in rivers. So it can measure COD, BOD, and nitrate, TOC, and TSS parameter in river water. These parameters tells about the pollution load in river due to industrial and municipal wastewater and non-point source pollution, which we have already discussed in previous slides. The BOD value in river often increases during periods of heavy rain and high river flows as organic matters is washed from the lands and farmyards. Uh, from the continuous monitoring of COD BOD, we also know the seasonal variations like in winters, in summers, or in rainy seasons. So we can create a baseline data. Continuous 24 into 7 monitoring helps you to identify the specific pollution events. That could be an accident or that could be an deliberately some event like oil spill from in navigation channel or man-made event like industrial discharge, untreated wastewater in night. So because some industry they want to save some cost, so they discharge untreated water in river in time in night time. So you can track the trends of pollution events, and you can also track defaulters who is dumping water without treating in the river. So it's a very necessary like to check baseline data in rivers to throughout the season, so we can set the guidelines. Government can work on the guidelines, what kind of water they have right now, and what further they can do for improvement of water quality in rivers. So now we can discuss about installations on rivers. Depending on site conditions, there are a few ways you can install these monitoring systems at river. One of them is extractive installation. Before installation, it is very important to check and evaluate the site locations, power availability bank for installation and fixing the whole panel, and maximum minimum flow during the peak and lean season. So we need all these data before selecting the right type of installation. If means power is available at site, then extractive installation could be preferred one. In this kind of installation, you can see a panel over here, right near the river, and you can see a pumping system here, which is bringing water from the river and pumping it to this flow cell, and all the sensors like spectral sensor for COD, BOD, and other sensor are dipped here, submerged here, and these sensors are connected with the controller, and you can see all the components related to water quality monitoring stations are all inside the panel and safe and secured. With this kind of installation, you will be able to maintain system very effectively. You can calibrate them easily, you can clean the sensor easily, and it will extend the deployment time between maintenance interval. This is another type of installation, in situ tap installation. So you can see the picture. There are some examples where you can see all the sensors are submerged, directly submerged in the river water, or maybe a lake or canal water, and sensors are connected to the controller, which is inside the panel, and panel is taking this, all the sensors and controller, they are taking power from a battery bank or solar panel. So you can see solar panel is mounted on top of the panel. This panel here, you can see the solar panel. So in this kind of installation, you don't require any pumping, because you are just dipping all the sensor right into the river water. To maintain the accuracy and repeatability of the measuring instrument, devices, controllers, and sensors, we need to calibrate them regularly. Calibration frequency is dependent on existing water quality at the site. You may require frequent calibration and cleaning of the sensors if water carries a heavy load of pollutions, of heavy high ranges of COD, BOD, and if fouling is dominant in river water. For calibration of sensor, we need laboratory result of the parameters, and that we can use to perform the site-specific calibration. Xylem has laboratory equipments, as Dr. Tao already explained, like we have laboratory equipments that help you make these laboratory measurements to perform accurate calibrations. So Xylem has a spectrophotometer for performing a measurement of nitrate and COD. We have oximeter for measuring BOD in laboratory. We have handheld device for measuring pH, conductivity, DO, and other physical parameters. So, by performing and these devices can be used for calibration and validation of online monitoring system for river application. By performing multiple calibration, we can achieve plus minus 5% of accuracy with the reference of laboratory results of COD BOD values. Success story for India. I will like since 2014, India's EPA, it's a Central Pollution Control Board, came up with the guidelines that made it mandatory for major industries and large industries to monitor water quality and volume of the treated discharge water for compliance and report data to CPCB. So you can see in the picture, like we have the GPRS and GSM modem is connected with the Xylem controller, WTW controller, and this controller is connected with the spectral sensor for COD, BOD measurement and TSS measurement, and the other sensor is sensor light is measuring pH. So both sensors are connected with Xylem controller, and controller is connected with GPRS modem, and data is sending through internet to CPCB server. So they are checking all the industries on a single platform, so they can check 24/7 anytime they can see their data. So Xylem Analytics, Xylem has installed and commissioned more than 1100 IQSN stations for several industries pan-India. Parameters being monitored include COD, BOD, TSS, pH, and flow for this application. Another success story, Xylem River Monitoring Stations has been chosen by one of the Indian State Pollution Control Board for monitoring river water quality at 12 different locations for different rivers. In this project, they are measuring parameters like COD, BOD, turbidity, temperature, DO, nitrate, ammonia, chloride, and depth. So if we talk about in totality in India, so we since 2014 we have installed more than 1200 spectral sensors for monitoring COD, BOD, TOC, and TSS, and other sensors. Here we are showing some pictures, like how we have already installed sensors, spectral sensor in wastewater. So this sensor you can see is installed in a channel after the treatment of water, and these sensors are connected with the controller, which is installed in panel. And you can see after using 3 and 4 years, the sensors, you can see the color has been changed due to a lot of dirt and suspended particles they have accumulated on the sensor body. While you can see the optics through which measurement is happening is so clear because we have ultrasonic cleaning here. So you can see the effect of ultrasonic cleaning because it is so clean. That is why this is so clean. So cleaning of optical windows is mandatory. So we have this ultrasonic cleaning if inbuilt within our sensor. So now comes to summary. I hope I could have explained about type of different pollution sources like non-point source and point source and non-point source, spectral sensors parameters like COD, BOD, TOC, and TSS, nitrate for river pollution check, and the different type of installations on river and lake as per their existing conditions of the river. And now, Michael, can you help for poll question number 4?
Certainly, Udit. Thank you very much for that very informative presentation. And we've just released our final poll. Would you like someone from Xylem to contact you about COD, BOD monitoring, or any of our WTW solutions? I'll just give the audience a second to respond. And then we'd like to open up the question and answer session and invite our audience to ask our 2 presenters any questions concerning the content that they heard today during the webinar. And we'll just give a couple more seconds for the audience to respond. Thank you very much. And if you would like to contact either Dr. Tao or Udit directly, their email addresses are listed here on the screen in front of you. We have received quite a few questions actually concerning whether or not we will be sharing the PowerPoint from both of our presenters today. And the answer is yes, we will be converting these to PDF and uploading them to our websites. So as of tomorrow, you will be able to visit the site and download these presentations if you'd like. And then again, feel free to contact either Dr. Tao or Udit directly with your questions. All right, so at this time, I'd like to invite the audience to type in the questions, any question they might have, into the GoToWebinar control panel, which is on your screen. There is a little box there that's entitled questions. Simply type your question into the chat box there. All right, so Udit and Dr. Tao, there's quite a few questions that are now queuing up. So I'll read out the first one, and I'll leave it between the two of you to decide who will respond. So the first question is, how accurate is the CarboVis for industrial wastewater?
Could I answer the questions?
Sure, Dr. Tao.
Yeah. Accurate actually for WTW CarboVis will be 5% for the total measurement. 5%.
Would you be able to expand a
Sorry.
little further on that?
5% mean 5% of the measurement value.
Okay, thank you for that.
Yeah.
The next question we have is, what is the installation process of this item? I'm assuming, yeah.
Can I take this question?
Please,
Michael?
Udit. Yeah.
Before installation, we need to check what kind of setup is there present there at site, like whether they have open channel and whether they have some pipeline over there. So if open channel is available, so this sensor is IP68 and it is made for submersible installation, so we can directly dip into the channel, so it can measure water quality there, and we can connect the sensor with the controller, which can be installed in a panel or maybe in a shade. So we can connect and we can give that controller to 230-volt AC power supply, so it can work immediately. And we need to calibrate the sensor with the local COD BOD values after taking sample from the outlet, and we can send them on the laboratory, and we can calibrate the sensor with those value, and it can work immediately.
Thank you very much, Udit. Let's move on to our next question. One of our audience is asking about how to protect the sensors in marine waters. Apparently, this individual is facing a lot of issues with algae accumulation on the sensor.
Can I take this question?
Yeah.
Please, Udit.
Marine water, I hope the salinity of the water is quite high, around 35 to 40,000. So in that case, we won't recommend this sensor. This sensor is more suitable for surface water like lakes and like rivers and canals, but not for sea applications. But if you find algae and other particles, so we can additionally put air cleaning system with this system, so it can clean repeatedly. After some time, we can set an interval to clean the sensor, so it can be cleaned via air cleaning also. Besides this, it is having ultrasonic cleaning inbuilt.
Excellent, thank you for that. Next question, how do these sensors, the CarboVis sensors, perform in extreme polluted waters that are a mix of industrial sewage and municipal sewage?
Michael, can you repeat the question once again?
Sure. How do these CarboVis sensors perform in extremely polluted waters? Polluted waters that are a combination or a mix of industrial and municipal sewage.
Could I answer these questions?
Sure, Doctor.
Yeah, of course. For the CarboVis can be used for the industrial or other some municipal waters. The main point is you should or how to calibrate your sensors by using the laboratory standard method. If you have calibrate, if you calibrate sensor well, you can get very good value for even you have the mixture of the water or the only the industrial or the municipal water, no problem.
Thanks, Dr. Tao. So would
Yes.
you say that the performance of these sensors are quite high in this kind of environment?
Yes.
Okay, thank you. So our next question is, their client often asks how the results of our BOD measurements are comparable to CarboVis. So CarboVis compared to BOD 5
Yes.
result?
Yes. Compare with BOD file. The main point is it's very similar as I have explained the last questions. You should have a good calibration. It means when you take samples, please firstly check the sensor value and then incubate the value. And after 5 days, record your real BOD file value. And when you get this 2 or 3 sets of this value, you just input in our WTW template. You will be get the infector, which will be recommended to input in the 2020 or the 284, the controller, and then you can start your measurement of BOD. As my experience, you can get a very good result. And you get the BOD value in time. No need to wait 5 days. It's very convenient.
Thank you for that, Dr. Tao. So one of the key questions or key words within these questions is concerning calibration. So on that note, how frequently should calibration be performed? And what is the procedure for calibration? Let's start with the first part. So how frequently should calibration be conducted?
Could answer these questions. I think the frequency, this is a very good question. The frequency is depends on the water, because if the wastewater is very stable, for example, the municipal wastewater in some country or in some area, the people not change so much. So the water, actually the components percentage, the components is stable. So you no need to calibrate very frequently, maybe half a year, 1 year, sometimes I think it will be enough. But if your wastewater changed frequently, I advise you to calibrate your sensor frequently. This is the first question. And sorry, the second question is what? Sorry, Michael.
Sure. Yeah. What is the procedure for calibration? If this is overly technical for this webinar, we can definitely take it offline if you need to.
Yes, it's offline. It's better. Yes. Simply explains you will need our Excel template to input your value, and you can get the factors automatically. If you're very interested for the procedure, please contact with me.
Great. Okay. So to the member in the audience, Ramsey, thank you for your question, and Dr. Tao will reply to you offline and get you the information that you need.
Yes.
All right. So there's just a couple more questions here. One is, can you compare the performance between the CarboVis and the SCAN COD sensor? Which is better in industrial and river monitoring for 24/7 monitoring?
Can I answer this question?
Please, Udit.
Since in our sensor we have this ultrasonic cleaning inbuilt, and we have titanium body, so and the scan, they do not have ultrasonic cleaning. They have to add additional air cleaning in that spectral sensor. So if we talk about performance and long-term stability of data, because we have both identical optics inside for our sensors for measuring windows and reference windows, while in scan they have very small sensor compared to us, so they have different sizes of their reference and optical windows. So if we talk about long-term data stability and accuracy, so in reverse and wastewater application, our system perform better than a scan.
Excellent. Thank you, Udit, for that. Well, I think we've covered most of the questions that we've been asked. Again, ladies and gentlemen, if you do have further questions, feel free to contact Dr. Tao or Udit directly at the email addresses that are listed on the screen. And of course, there will be contact information included in the follow-up email that will be coming out to you shortly within the next 30 to 60 minutes. So just a final thank you to Dr. Tao in Tokyo and to Udit in Delhi, India. Thank you both, gentlemen, for your time today. Would you like to, the final word, final closing?
Thank you, Michael, for giving this opportunity and help for this webinar. And thank you very much, all the attendees for attend this webinar. Thank you very much.
Yes, thank you. Thank you, everyone.
Thank you, everyone. Have a great day and stay safe. Goodbye.
Bye-bye.
Bye-bye.